Okay, so right now we're going to be talking about the properties of logs. Now, from the last lesson, we talked about how logs are related to exponents. Now, if logs are so related to exponents, they should have similar properties. So in order to explain some of the properties of logs, I'd like to do a quick review of some of the properties that we know of exponents, such as if you have 2 to the power of 3, multiplied by 2 to the power of 4, well, that really means we've got 3 twos being multiplied together times 4 more 2's being multiplied together. Altogether, that's 7 2's. Now notice what happened is because we were multiplying those two terms, 2 to the power of 3 and 2 to the power of 4 together, we were able to add the exponents. Now remember that log is all about asking what is the exponent. So if you've got two logs that are being added together, remember log gives you the exponent. It must be because they were being multiplied together. So these two statements are the same. So if you've got two logs that have the exact same base, remember that was important down here, that we have both of these bases be 2. Same with these logs. All of these bases need to be the same. So if your bases are the same and you've got these two logs being added together, we can combine them into one log, where the m and the n in that situation are just going to be multiplied. Okay, or vice versa. If I've got a log and I've got two things being multiplied together in that log, I can separate the log out into that addition. This is what is referred to as the product property of logarithms. Okay, in the next one, if I had 3 to the power of 5 over 3 to the power of 2, just remember that's going to be 5 3's and 2 3's. And when we simplify, we'd only have 3 3's. Or in other words, we can subtract the exponents. And that's how we get that answer. Okay? So, same thing happens with logs. If we are subtracting the logs, well, that could be the same as dividing those two numbers inside of the log. Okay, so that's another way that we can either condense or expand a log. If you see two logs with the same base being subtracted, you would take the first one, that first number, put it as the numerator, the second number, put it as the denominator, and you can stick it into a single log. For the next one, so that was quotient property. Next one, power property, which is if I've got 3 squared to the power of, let's say, 5, well, I'm going to get 5 groups of 3 squareds. I'm going to have 10 3's. So this is the property where you multiply two exponents together. Okay, so we've got, remember, log basically represents the exponent, and it is being multiplied by an n. So that would be the same as log of base b, so the same base, but this time we're raising m to that other power. Both of these statements are the same. So you can take a number that you're multiplying log by a number and then change it into an exponent on the inside of the log. Okay, so those are the 3 properties of logarithms that we are going to be using, along with their accompanying exponential properties that they come from. So now let's use some of these properties. Make sure that you've got this table that I've drawn on written into your notes. It is important that you have that for reference, especially as I can't keep it on the screen while we go through some of these equations. So first, rewriting into exponential form and logarithmic form. I'll do a quick review of that. Go to the previous lesson if you'd like to see more. So first, we've got our logs. We're going to rewrite it with an exponent of base of 36. The exponent was equal to a -2, and 6 to the power of -2 is equal to 1 over 36. Okay, this log has a base of 9, and the log is asking, what is the power? So log, what is the power of 9? That will equal a 1. Well, 9 to the power of 0 is what equals 1. Now to rewrite these in their logarithmic form, we're going to have a log. It's going to have the same base as the exponent. So 18 to the power of what would equal a 324? The answer is 2. 18 to the power of 2 will equal 324. Once again, log, same base of a 5. Let's rewrite that up. I am not having luck writing a decent 5. So log base 5. 5 to the power of what is equal to a 25? 2. Okay, now let's talk about expressions. So, and evaluating them. One, you could simply use a calculator. Depending upon the calculator you're using, this can be more or less tricky. But look for that log button on your calculator. However, many calculators do not allow you to change the base. And that's where this could get tricky. I would recommend using Desmos for some of your evaluating needs. However, for a lot of these problems that we're going to do, Desmos is unnecessary. So in order to evaluate this, remember we are saying what is the power of 6 that gives us 216? That's what that log is asking. So let's just start multiplying some 6's together. If I do 6 times a 6, well, that would give me 36. If I do 6 times 6 times 6, that will give me 216. So the answer we're looking for is 6 to the power of 3. Or, well, I should say, the power we're looking for is 3. That's the answer, because that's what the log was asking for. What power of 6 equals a 216? Power of 3. Okay? So in the next problem, what power of 4 equals a 16? Well, we know 4 times 4 would equal 16, so that was twice. So 4 to the power of 2 would equal 16. So the power would be 2. We could also write this another way, in that 6 to the power of 3 was equal to the 216. 4 to the power of 2 is equal to 16. And we just need to pay attention to the fact that the exponent that would create it is the answer to these questions. All right, so now 7 to the power of what is going to equal 343? Well, let's see, 7 times 7 would be 49, and then 49 times by another 7 would equal 343. So it would be 7 to the power of 3, which means that equals 3. 3 to the power of what equals 27? Well, 3 times 3 would equal 9, times 3 does equal 27. So 3 to the power of 3. So the answer there is 3. So that's how you're going to evaluate the expressions. Other than that, it's sometimes, and one of the great things about logs is it helps us to find exponents that we could not normally figure out. So just as a little helpful thing, if you are going to use Desmos to do a log, I normally just type log, and then I do a shift and your minus key. So that's an underscore, and now you can type in a base for the logarithm. So 6 to the power of what is equal to 500. Notice 6 would not normally, if this was your problem that you were sent to evaluate, you wouldn't be able to do it the way that we just did it, because 6 does not multiply an even number of times to get a 500. So we would have this odd decimal, 6 to the power of 3.46843. That's what's going to equal 500. But that's just me quickly showing how to use Desmos in order to do that work. All right, so next we're going to condense. So this is where we are now going to use those properties that I talked about earlier. So first I see the power property. I know it's the power property because I'm multiplying a number outside of the log. So 2 times log of 8 is the same statement as log of 8 to the power of 2. Or in other words, log of 64. Okay, in this next one, now that division, don't let that fool you. So we talked about how to multiply a number outside. This is dividing a number outside, but dividing by a 2 is really just the same as multiplying by a 1/2. This is still a power, a power property. So because I'm multiplying by a 1/2, I can now rewrite this as log of 7 to the power of 1/2. Or in other words, another way we could write that, log square root of 7. Any of those two could be the proper way to write it. I do also want to clarify that whenever you see a log that does not have a base, up here we kept on seeing logs with bases, and down here not so much. Whenever you don't see the base specified, the base is 10. It's just assumed. We have a base 10 number system. You have 10 fingers on your hand. We use log base 10 as the default. So whenever the number isn't pointed out, it's going to be a base 10. Similar to when you do a square root, you don't have to say that the index is a 2. If no number is there, we assume it's a 2. Same kind of principle. All right, so now we see 2 logs, both of them base 10, being subtracted. So I can rewrite this now as a log of base 10, where we have 5 over 8. Okay, so there's our quotient property. And then this time, once again, we see 2 logs, same base, this time being added. So we'd use our power property, which means we'll have log of 12 times 5. So log of 60. All right, in this one, we are now going to expand them back out. So in the other one, we were condensing them into single statements. This time, we're just going to do those same properties, but backwards. Here, I see an exponent inside of my log. So the power property lets me know I can bring that forward. And then it still has 12 on the inside. This one, just like before, they're trying to make it difficult by including a radical in there. So let's just quickly change that radical into an exponent. So we're going to change that to log of 6 to the power of 1/3, because it was a cubed root. So because we are have that power to 1/3, that means this is 1/3 log of 6. Or in other words, log of 6 over 3. Okay, right here we notice two numbers being multiplied on the inside. That is the same as if we add those two as separate logs. On the inside, we've got two logs being divided, so we'll use our quotient property. So the numerator is going to be the first one, log 6, minus log of 11. Okay, so hopefully those properties are fairly easy, and as you're able to use it, the more you practice it, you're going to be able to recognize them and use them more readily. Just make sure to keep this table handy and easy to see.